Hello, welcome to this video. This video introduces how intuition helps quant in interview or daily works. Senior and experienced person usually make a decision by intuition rather than quantity. These decisions are like yes or no questions, whether A is larger or smaller than B problems. So in my opinion, intuition usually means you can understand and explain complicated things in a very straightforward way. Let's take the first example. So this example is about Asian option versus European option. The question is whether Asian option is cheaper or more expensive than European option. This question also appears many times in Morgan Stanley written test. The question gives you two payoff. The first one for European option, we don't need to mention that. Another one is Asian option. With the underlying is the time-weighted average of the underlying asset price. So if you don't go with intuition and you just calculate the expected value of your Asian option payoff, I do believe this would be very complicated for a fresh graduate or very new guy who just touch base of stochastic calculus. I will not choose this way. So think about in another way. You can think about it that the average usually has a smaller volatility than the underlying price itself because you are doing the average, right? So, and we also know that usually the option is an increasing function of implied vol. This is true for most vanilla style options. It's not true for binary or other exotic option, but usually true for vanilla one. So in this case, from this question, in this case, the Asian option has a smaller value than European option just because its vol is smaller. So from this question, you will see that there's no math formula you need to be deal with. The only thing you need to do is the vol. The only thing you need to recognize is the vol of average is smaller than itself, and the relationship between the vol and option price. Let's take the second example. The second example is about one touch, and there's two payoffs. One is American, another one is European. We dealt this question before, so if you want to check more details about reflection principle and one-touch options, please check my previous videos. There is two types of the payoff. One is American. So this payoff is that between the 0 and a capital T, if anytime your underlying touch some barriers, let's say $100, then you got $1. Otherwise, if you never touch that, you got $0. For European style, the payoff is quite similar. So, but it's only count for in the maturity when in the capital T, if the S of the capital T is larger than something, you got $1. If it is smaller than something, you got $0. And in this question, what we are using is reflection principle. So here we are not doing reflection principles in details. But what I want to suggest to you guys is that don't remember or just memorizing this principle. You need to understand this principle and make it as intuition in your brain rather than memorizing it. So this principle says if there are two paths and they both hit the target, they share the same path before the target. And after they touch the target, there will be reflection, so they will be mirror to each other. So in this case, if there is two paths which hit the target, one out of these two paths leads to the final underlying price S at a capital T larger than target. Another path will lead to your final ST, your S at capital T smaller than target. So in this case, you will see that the two paths both hit the target. That's the American style. So you got $2. One pass, you got $1, and you got two pass, they both hit, you got $2. But only one out of this two pocket for European style, you can get $1 because there is one S larger than target, there is another one less than target. So in this case, your American value will be exactly 2 times than your European style. Another simple question or another simple example is drunk man or random walk. So in this case, you have a drunk man. It moved to the left and moved to the right with a simple equal probability, 50% to 50%. And what we want to know is that what's the probability of it arrives at A before it arrives at B. You don't need to understand the martingale here. Actually, they're testing your martingale and how to transfer some non-martingale to martingale, which is the change of measure things. You don't need to do that. You just use your intuition, because A is more far away than B, so its probability will be less than B, right? That's it. And the two sum up together will be 1 because there's only 2 results. Either arrive A or arrive B. That's the 2 results. And if we increase the probability, let's say move to the right, increase to 60%, the another one decrease to 40%, you will see the probability of arrives B will be increased. That's the intuition. You don't need to understand martingale, change of measure things. You don't need to do that. The last example is Bayes probability. The Bayes probability essentially is based on your result to guess the probability of the reason. What's the reason causing this result? A classical example is that 1,000 coins and we have 1 unfair coins there, which is double-headed, and we random pick one and we toss it 10 times. And in this 10 times, we got 10 heads. This is so weird because usually you have 5 head, 5 tails, but if you got 10 heads, that's so weird, right? So in this case, you will see that the probability of this random pick one is unfair. This probability will be very large. So if we don't do this result, if we don't do this experiment, this 10 tosses, it's 1 over 1,000, which is only 0.1%. But in this case, if you calculate by Bayes probability, it's much larger than 0.1%. It's actually 50%, which is much larger because you do the experiment and this experiment has some weird result. So it increases your confidence that this coin is unfair coin. And if you increase the tosses and you got more heads, it will increase this probability again because it's really, really weird, right? It's more weird than before. So you have more confidence that this coin is an unfair coin. But the weakness of the Bayes probabilities here is very apparent because your solely depends on your past result, which is not correct because you just depends on the past experience, you depends on the historical data. And the assumption there is that your sample space will not change. If it change, it's another different story. Alright, so that's all for today's video. If you like this video, you can give me a like and subscribe my channel. And thanks for watching. I really think that intuition is more important than the math formula itself. If you have a very good intuition, you have the big picture, but if you just dig into the math, you will lose the big picture. Alright, thanks for watching.